Hello everyone.
Hello 老师，好的老师
Hello, good afternoon.
Hello 老
Um,
师
，Good afternoon
good
老师
afternoon. It's time for
Good
class.
afternoon. Good
Okay.
afternoon. All
，OK，
right.
，OK 老师
Okay. Last class we studied the machining tools and the cutting tools. Let's have a review. At first, as we know, a machine tools is there are a variety of machine tools. Machine tools have
真的
to be classified for the convenience of the distinguishing application and, and the management. There are many ways in which machine tools can be disclassified as follows. Based on the cutting tools used on machine tools, they are classified lathe, milling machine, drilling machine, and planer and shaper, grinding machine, boring machine, broaching machine, threading machine, gear cutting machine, sewing machine, and other machines. This is based on the cutting tools used on the machine tools. And the most important is the laser or laser machines. This is most important. So we studied as a machine lathe is most important machine tools. This is a lathe, and this is a drilling machine, and this is a grinding machine, and this is a planer machine and a milling machine. This is a milling machine, and based on the degree of the specialization, they are generally they are described general purpose machine tools, specialized machine tools, special purpose machine tools, and based on the weight of the machine tools, they are classified for the light duty machine tools, medium duty machine tools, and large duty machine, and heavy duty machine, and super heavy duty machines. And other classifications based on the standard accuracy machine tools and high precision machine tools and the automatic machine tools and semi-automatic machine tools and the multi-spider machine tools and the multi-cutter machine tools. In general, machine tools are classified based on the machining feature firstly, and then described further based on some characteristics such as semi-automatic or multi-cutter machine tool, universal cylindrical grinding machine with high precision. This is the technical parameters and dimension series of machine tools. The technical parameters are various technical data to express the size and the machine capacity of it. It's including the primary parameter, second primary parameter, and the structural dimension of major assembly, traveling distance of major assembly, various moving speeds and speed series, power of motors, overall dimension of the machine tool. And the most important is primary primary parameter. It reflects the maximal working capacity, and then is the second parameters. This is the number of the spindle, the maximal span, and the maximal length of the work. And then is the model of the machines. Model of machine tools. Uh, it, uh, it can use this figure to express of the general purpose of machine tools. We should as an example is CA 6140. The first is C. This means the lathe. The Chinese is 车床. So in China, this is the first is the C. This is the type of what the machine is. This is lathe. Mm, Maybe next week we will have the uh, experiment for to uh, see the lathe machine and the grinding machines. And this is a C is means the lathe, and A stands for the structural feature of the lathe. A is it stands for the uh, feature structural feature. And the six means the lathe falls into the group of floor type and the horizontal lathe. The six means that the group of the follow type and the horizontal lathe. And one means that the lathe belongs to the horizontal lathe series. And this is 40. 40 means the primary parameter. This is the primary parameter with the max turning diameter is 400 millimeter. This is the primary. The last is the primary parameters. And this is the grinding machine. And so the first is grinding means the grinding machine. This is the 磨床. This is in China. This is the first is M, and then is G. G stands for high pressure. And one means the cylindrical grinding machine group, and the four means that the universal cylindrical grinding machine series, and the 32 means that the maxi grinding diameter is 320 millimeters. We must know that the last two number is primary the maximum grinding diameter, or the primary this is the primary parameters. This is we should know that the last two number is the primary parameters. And then we study the methods of generating surface. There are several basic surface faults. The first is plane, and this is a cylindrical surface. cylindrical surface and the straight countered surface and involute surface. This is sign of the basic surface forms. And then we studied the methods of generating surface and the kinematical analysis of the machine tools. The geometrical surface is defined as the trace obtained in the machine of one geometrical generating line called the generax one. This is one along other geometrical generating line called the directress. This is directress. This is some of the shape to generating surface. This is a gear. This is a gear, and this is a column. Both of the line of the gut, these two lines is generally called the generating lines. These two lines are called the generating lines. These two lines, 1 and 2, and this is this and this is this is generating relax, and this is a director trace. And the some methods to generating surface. The first is the forming method. This is a forming method. This is a method of using a forming tools. Using a forming tools. This is forming tools to form a generating line and processing the workpiece. Generally, gears usually use this forming method to generating surface. And 2 is a trace method. Trace method is a method of forming the required surface shape by the movement trace of the tool tip. This is this picture shows the trace method. This is the trace. This is the trace method. In this picture shows, and the third is tangent method. The tangent method is a method in which the multiply this has a multiply cutting point on circular facial tool jointly for the designed workpiece surface shape. From this picture, we can see that there are multi-cutting points. There are multi-cutting points to generating surface. This is the tangent method. And the 4 is the generating method. This is a method of using the workpiece and the tool to generate a cutting machine and to form workpiece surface. From this picture, we can see that using the workpiece. This is a workpiece, and this is a tool, and this is a workpiece to generate the cutting method cutting machine with the cutting machine to form workpiece surface. Generally, the surface to machine is produced by forming or by generating or by the combination of these two fundamental methods. So these two methods, generating and forming, is most important surface generating methods. This is most two important. Generating and forming is the most important methods to generating the surface. Okay, this is we should know. And then is analysis. We analysis the of the machine tools machine. The simple forming machine means that independent forming machine includes the single rotation or a nano machine. This is simple forming machines. And B is a compared forming machine means that the independent forming machine consists of two or more rotations or nano machines. They have the um, rotations and the nano machines of the tools. And some auxiliary machine, including the engaging, engaging and disengaging, and the changing the speed of the drive and the feed machine. And C is the clamping and the loosening of the workpiece. And D is the indexing machines. And the machine tools must be of three basic parts. The first is the elements. Executive elements such as spindle, tool rest, and work table. And two important parts is power source such as motors. And three is a transmitting device. Device is including the transmit power and the machine. This is three basic parts of the machine tools. They are executive elements, power source, and the transmitting devices. This is the three basic parts we should know. The machines, uh, feature and the composite of the lathe. We will study these three parts: executive elements, power source. In this spindle is very important, and the tool rest and the work table, and the machine and the transmit power and the machine. This is most important three basic parts. Okay. And the transmission connects. It's including the power source, transmitting devices, executive numbers, all of executive numbers. This is called the transmission chains. There are two kinds of the transmission chains. The first is external connection transmission chains. In this is the motor. This is external connection transmission chains, and then is interconnection transmission chains. And this is inter internal connection transmission chains. Like this. This is a spindle, and this is a motor. So this is the external connection transmission chains, and this is external connection transmission chains and the inter nano connection transmission chains. And then is the transmission and principles diagram. This is in order to facilitate the study of the transmission connection of the machine tools. The transmission principle and the transmission route are represented by some simple symbols. The first is the motor. This is the motor, and this is a spider. This is a spider, and this is the tools. This is the tools, machine tools, and this is hobbling, and this is a sensors mechanism. There are two input and one output. This is a sensors machine, and this is a replacement machine, and this one spot line is a mechanical contact, and this two spot line is electrical contact, and this is a plaza, and this is the NC system, or the new numerical control system. And then we studied the basic contents, the basic content of the Knurling. Most lathes are compatible of both external and internal machine operations. And the external cylindrical machine operations include the straight turning, table turning grooves, facing, threading, knurling, and cutting off stock. And the internal cylindrical machining operation include all common home machining operations such as drilling, boring, reaming, counter boring, counter seeking, and the center dragging, and tapling, and the threading with single point cutting tools. And this is a lathe, and some lathe operations. This is some lathe operations.
车靴加工工艺系统 由车床、刀具、夹具、工件等基本要素构成。
Huh?
Is it just me or
Yeah, I don't know. Even
What's going on?
Austin?
patience? Just relax. Come back.
Muhammadu Sayyid.
Hello?
Hello, Laoshi. We couldn't hear
Hello,
you.
can you hear
Everything
me?
just stopped. Yeah.
Yeah,
Now we
Laushi,
can
what's
hear
up
you.
in there?
Oh, I'm so sorry. Maybe my internet is not very well.
It's okay, Laoshi.
Oh, right. Okay.
It's
I'll
okay,
continue.
Laoshi.
Oh, okay. This is the layout of the CA CA 6140 lathe. And the first one is head stock. The first is head stock, and the three is component raised. This is component raised, and then is tail stock. And then the five is the bed. The five is the bed. This is the bed, and this is and this maybe this. This is uh a power, and this is a feed box. This part is the most important of lathe. This part is most important of the lathe. And the transmission system diagram of the machine tools of the machine tool is generally used to analyze the transmission situation of machine tools. Transmission systems. The diagram is a scratch map used for indicating all machine tools motions. In the drawing, a specific drive motion mechanism of the transmission chain is expressed by simple prescribed symbol, and choose the number of the gear and the one gear. 3. The number of the one lead to a screw, a pulley pulley diameter, power and revolution of the electrical motor should also be marked on the specific drive member. The drive mechanisms in the transmission chain are arranged in turn in the line of the machine transmitting squares. Transmitting system diagram is made in the form of the development drawing in the outline and counter of the machine tools. And this figure is a block diagram of the lathe transmitting systems. The first is the motor. The motor is the power source. This is a power source. This is a motor, and through the pulley, the power transmit to the head stock, and then to transmit to the spindles, through the chuck and the work where the rotate. This make the workpiece to the rotation, and the other power will transmit to the end gear box, and through the feeder gear box. The power if transmit to the leader screw and transmit to the carriage. It's can used to threading, and if the power transmits to the feeder road, and then transmits to the carriage. It will have the longitudinal or cross motions. And this is the transmission system diagram. This is the head stock part, and this part is the feeder box part, and this is the apron. This is a 3A transmission in part, and the transmission systems under the lathe must have two machines. One is the primary machine, and the other is a nano machine of the cutter. This is a feed machine. This is the move of the tools. This is the move of the tools. There are two parts. In order to realize these machines, the transmission systems of the lathe should have these two transmission chains as follows. The transmission chains of the primary machine. This is to realize the primary machine, and then is transmission chains of the longitudinal feed machine. This is to realize the longitudinal feed machine, and this two transmission chains of the transverse feed machine is to realize the feed transverse machines. And this is transmission chains of the primary machines from this figure. This is a spider. This is spider, and the first is this is shaft one. This is through the motor and the pulley. The the power will transmit to the shaft 1. And this M1 is bi-directional multi-piece friction in clutch. This M1, and this one, this M1, this directional multi-piece friction clutch is symboled on the shaft. This is a symboled on the shaft 1 to make the spindle, or this spindle to rotate. This can determine the spindle is counterclockwise or the clockwise or stop. Or this M1 can finally determine the spindles is counterclocked clockwise and stop. If the spindle want to rotate counterclockwise, this M1, the friction clutch should place on the left. And if the spindle wants to rotate with clockwise, it should be the right. And if the M1 is the middle position, the spindle is stop. So the bidirectional multi-piece friction clutch 1 can finally determine the rotation ways of the spindle. And then when the machine of the shaft 1 is transmit this way to determine the rotation of the spindle. This is through the M1. The power will transmit to the shaft 2, and then transfer the shaft 3. The power will transmit. And then the spindle 4. The spindle 4. This is spindle 4. Through the 2 transmission route. When the slide gear and when the slider gear, this is all this and this is a gear. This gear can transmit the power from shaft 1 to in this picture. This can transmit the power also from shaft 1 to shaft 2, the shaft 3, and the shaft 4, 5, and 6. This is through these gears, the power can transmit. The machine of the shaft 1, the machine of the shaft 1 is shaft 1 transmits if it is left or right, it can transmit the power. or from shaft 1 to shaft 2 to 3. This is the way the way of the power or transmit. And then if the power directly transmits to the shaft or spindle or 6, the spindle has high speed, and if so this way the power all transmits from shaft 3 to shaft 4, and then the powers from this from through the shaft 4 to 5, and finally transmits from the spindle, and the speed is different from this. This process, the spindle will have different gears. The spindle finally will have the different rotating speed. This is this is a transmission routing and route of this is the transmission chain of the primary machine. So this process you can understand by yourself. Or this is the power source. So this pulley. This is the power source from the power is from the motor, and then transmits. The power will transmit to the shaft 1. The power will transmit to the shaft 1, and the shaft 1, the M1 is bidirectional multi-pace friction in clutch, and through this it can the different place of the M1 and the friction clutch. The finally the spindle will have a different rotating direction and or stop. And if so this gears the and then the power all will transmit from shaft 1 to shaft 2, and if this to and if this in the right place and the right place the spindle will have a different rotating direction, and then if the power also this gear transmits to the spindle, the speed is different from the when the gear is the power is transmits from shaft 3 to transmit to the shaft 4, and through the shaft 4 to transmit the shaft 5, and finally it transmits from shaft 5 to the spindle. The speed is different from this. So this is transmission ways of the primary machines. We can use this 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 to express the transmission route express of the primary machine, and we can use this. This is the transmission route. And the first is the motor, and through the pulley gears, and this is the chapter 1. And if want to the if the M1 is the left, and the gear, this is the gear, gear from this picture we can see from these two gears, 56 to 38, or the these two gears, or the 51 to 40, maybe the 40 51, and the 43, the 43, if these two gears is these two gears is the mesh, and if the M1 is a bidirectional multi-piece friction clutch. M1 is right place. In this picture, M1 is right place. These two gears will mesh. The 50 A and the 40 34. They these two gear, and and then the power will transmit from the shaft 1 to shaft 2. This is a three ways of the gear mesh. Three. Shaft 1 to shaft 2. There are three ways. 39 to 41, 39 to 41, and 39 to 41, and these two ways. And then the power will transmit from shaft 2 to shaft 3, and then this has two and then this has two ways. The first is through shaft 3A to shaft 6. This is a spiral. This is 63 to 50. In this picture, all we can see is this. This is one way, and the other, if the gears mesh with these ways, the power will transmit from shaft 3 to shaft 4, and these two ways to shaft 4 to shaft 5, and through the M2. Oh, this is a friction clutch. So this transmission route expression, this transmission route, we can know the transmission in process of the primary machine. And we can through this to understand the transmission route. Okay, each time have a break. It's time for it's time we have a break. Okay, let's
Yes,
have a break.
Laoshi. Yes, Laoshi.
OK，
Okay,
老
okay,
师。
老师. Yeah, now your voice is high. Tatiana.
that rotates the work. One in the lathe. Grooving operate planing the work against a rotation.
Discuss the basic tool is fed on workpiece. The operation. Discuss the basic operation. Discuss the basic operation. Tool is fed.
Hello everyone, it's time for class.
OK，老师。
Yes, 老师。
Okay. Last class we studied the transmission route of the primary machine. We should know the transmission route by shaft 1 to shaft 2 to shaft 3 and then to shaft 4, 5 or to 6 and 6 is the spindle. This is mainly due to the different gears mesh. It can through the different gears mesh. We should understand this part. This is many so the first we should know we should find at first we should find the shaft at first, and then the different gears mesh will have different rotate way of the spiral. This is through this M1. M1 is a bi-directional multi-piece friction clutch. So the M1 and so the this is and M2 and different gears mesh will have a different speed. We should understand this transmission route express of the primary machine. We should understand this. And then from the primary drive system diagram, we can know that the first a multi-piece friction in clutch M1 is assembled on shaft 1 to make a spiral or rotate counterclockwise or clockwise or stop. This is determined by the M1 multi-piece friction clutch. Finally determine the rotation of the spiral. The spiral of the cross one counterclockwise or clockwise or the stop. And two, join a gear to shaft with single fixed key or the fixed gear, spiral or solid gear or smooth surface. This is joint of the shaft with a single fixed gear. And the sliding gear this spiral is shafted to right and to mesh with M2. Spiral can obtain the slow revolution with 10 to 300 row per meters. When M2 is disengaged, the motion is directly transmitted to shaft from shaft 3. spider can obtain 6 level high speed. This can the speed is through the different shaft. And 2 is the transmission chain of the feed machine. And then is the chain of the feed machine. This is they are used primarily. They are used primarily for cylindrical cooling and facing, in order to reduce the wear of the lead screw and ensure the transmission accuracy of the thread cooling. The power feed is driven by means of a feed rod instead of a lead screw. Its function is to make tool wrist more longitudinal or transversely at a required speed. It consists of threading transmission chains and power-driven feed transmission chain. To find the first and the last part is through the spider and the tool wrist. This is the transmission in chain of the feed machine. This is the process. The threading transmission chain. In the lathe of CA 6140, can be used to machine 4 kinds of standard threaders: metrical system, British system, or model thread, and diameter pitch thread. No matter whether it is right hand or left hand, it can also be used to machine large lead threads, not standard threads and precision threads, to cut an accurate thread. It is essential to maintain the correct relationship between the movement of the carriage and the RPM of the work. This can be arranged by means of the lead screw, which is driven by the chain of the gears from the spider. This is the threading transmission chains, and this is the video of the lathe operations.
Discuss the basic operation in the lathe. Facing is an operation which produces flat surfaces. Facing tool, workpiece, chuck. In this operation, the tool is fed at right angles to the axis of the workpiece. It reduces the length of the workpiece. Various types of lathe operation we'll discuss in the next videos. Turning operation. In this video, we will discuss the turning operation of the lathe. Turning is the machining operation in which excess material is removed by rotating the workpiece against a cutting tool. F, depth of cut. Knurling operation. In this video, we will discuss about knurling operation in the lathe. It is the process of indentation of various forms on cylindrical surfaces. Knurling tool, workpiece. A knurl tool is held in tool post and pressed against the rotating work. It is done to provide grip on holders and screw heads. Grooving. In this video, we are going to see about grooving operation. Grooving is also known as recessing, undercutting, or necking. Consider a workpiece held in lathe. The grooving tool is fed crosswise against the rotating workpiece. A groove is the location of an indentation in the part. This indentation can be square, round, or angular in the shape. The function of a groove is usually to allow room for a fitting part such as a rubber O-ring. It could also be the place where another part fits into this part. Grooves also provide a relief in the backside of a thread where the thread terminates. Drilling. In this video, we will discuss the drilling operation of the lathe. It is the process of making holes on workpiece. The drill is fed slowly into the workpiece, which is revolving in a chuck. Chuck. Workpiece. Drill tool. The drill is held stationary in the tailstock spindle. Reaming. In this video, we are going to see about reaming. Reaming is the operation of finishing and sizing a hole which has been previously drilled or bored. Consider a workpiece held in lathe. The tool used is called reamer, which has multiple cutting edges. The reamer is held on the tailstock spindle either direct or through a drill chuck and is held stationary while the work is revolved at a very slow speed. The feed varies from 0.5 to 2 mm per revolution. Hence, reaming is done. Boring operation. In this video, we will discuss the boring operation on the lathe. Boring is the operation of enlarging the previously drilled hole with the aid of single point cutting tool called boring tool.
Okay, this is the lathe operations. And then we study the lathe cutters. There are many kinds of the lathe cutters. Common used lathe cutters and the usages are shown in these figures. There are different types of the lathe cutters. External cylindrical turning tools are used to for turning external cylindrical and the coin call, and the one and the first one this is 45-degree bend turning in tools, and two this is a 19-degree external turning tools. And the 3 and line is a thread and is a thread tools, and the 4 in this we can see that this is a 35-degree external turning tools, and 5 and 5 and 5 and 5 in this 5 in this is 4 turning tools, and this is 5. This is 4 turning tools, and 6 in this is 90-degree shift handle turning tools, and the 6 and the 8 is and 6 and the 8 we can see that this is grooving tools, and the line this 9 is a threading, and this is a threading tools, and the 10 and 11 and 10 and 11 is a bowling in counter. This is a different kind of the lathe counters. From on previous video, we can know that the different lathe counters will have different works. Well, external cylindrical turning tools are used for turning external cylindrical and coin surface. They are straightly turning tools and the bent turning tools. The bent turning tools has a high versatility and can be used for cylindrical turning, facing, and the chamfering. The lathe counters with the leading cutting edge angle, or when the leading cutting edge angle is 90 degrees, can be used for turning multi-diameter shaft. Shoulders of the shaft and slant shafts with a low rigid channel. And then the lathe cutter have 4 types of the structure. I will 4 type structure of forms. The first is this is a solid tools. This is solid tools, and this is a braced insert, and 3 is climbed insert, and 4 is indexing insert. This is a lathe cutters structure forms. The solid tool is made of high speed steel, and this is a solid tools. The lathe cutter with and the cut with the braced inset means that the cemented carbide insert is braced on the shack by means of bracing method, and this is a climbed inset. From this picture shows the lathe cutters with climbed insert, which is climbed mechanically onto the shack and can be resharpened by grinding if necessary. And for many applications, it is more economical to clamp the insert to the shack, and the lathe is the climbed indexing insert is similar. This is similar. This is similar to the cutter shown in this picture. This indexing insert is similar the climbed insert, but this indexing insert is a title different insert. The indexing insert have several cutting edges. There are several cutting edges. We can see from this picture. When one edge comes down, the insert can be indexed and clamped and put into turning operation again. Commonly used the cemented carbide indexing insert. This is a lathe cutter. This is a lathe cutter, and the generally a structural forms. This is they are solid tools raised inserts, climbed inserts, and indexing inserts. There are two types of the structural forms. And the lathe counters usually common use the cemented carbide indexing insert. They are different type. The first is triangular insert, and this all ABC is triangular insert, and D is a square insert, and E is a pentangle insert, and F is a circular insert. This is a cemented carbide indexing insert. And the 2.3 is grinding wheels and the grinding machines. And this is part 3. At the first is introduction. What is grinding? Grinding is a process carried out with a grinding wheel made up of the abrasive grains for removing very fine quantities of material from the workpiece surface. The required size of the abrasive grains are mixed with the binding materials and then processed into a disc shape. Then to the disc shape with given diameter and thickness. This can be comparable to the milling process with the infinite number of the cutting edge. This is grinding. And the grinding is a process used for the following purpose. This is the purpose of the grinding. At first, machining materials which are too hard for other machining process to cut, and second is close dimensional accuracy of the order of 0.3 to 0.5, and 3 is a high surface finish, such as the RE equal 0.50 to 1.25, and this content of the 25% of all the machining processes used the roughing and finishing. And the abrasive grains are basically spherical in shape, with the high sharp point, which act as the cutting edge. All grains are of the random orientations and to right angles presented to the work material can vary from positive to a large negative value. Sometimes graters slide rather than cut because of its orientation, and the depth of the cutter taken by each of the grain is very small. However, a large number of the graters act simultaneously, and hence the material removed is large. The cutting speeds employed are also high. As a result, the chips produced are very small and red hot. They often get welded easily to the abrasive grain or to the workpiece. Thus, the grinding process is very inefficient one compared to the conventional metal cutting processes. This is the depth of the cutter taken by each of the grain is very small. And then is a video introduce the types of grinding machines and the operation.
A grinder is commonly used to precisely shape and finish the given materials with low surface roughness and high surface quality. Grinding machine is a type of machine used to grind the workpiece. It basically uses emery or an abrasive wheel as the cutting tool. The grinding process is truly a chip-producing machining process. The rough surface of the abrasive wheel, known as grinder, spreads into small portions of the workpiece as required. The grinding process is capable of producing very accurate sizes, equally accurate flatness, or circle, and extremely good surface finish. It is capable of machining high-speed steel, which cannot be done by other machining processes. Artificially manufactured abrasives like silicon carbide and aluminum oxide are used in grinding wheel due to their high purity. A grinding wheel, or bonded abrasive, is made up of thousands of tiny abrasive particles, inserted in metric calls as bond. A bond refers to the substance of which the matrix of the grinding wheel is made. In bonded abrasives, porosity is essential to provide clearance for the chips being produced and to provide cooling, otherwise chips would interfere with the grinding process. An abrasive is the second hardest material compared to diamond. In addition to hardness, an important characteristic called friability. It is the ability of abrasive grains to break into small pieces. High friability indicates low strength or low fracture resistance of the abrasive. Bonded abrasive are marked with a standardization system of letters and numbers, indicating the type of abrasive, grain size, grade, structure, and bond type. When a grinding wheel is applied to the workpiece, the sharp edges of the abrasive grains after using certain amount of time, it'll lose their cutting effect and become dull. At that stage, the abrasive grains should either split or form new edges, or it should break away from the wheel, exposing the next layer of grains to do work. If the dulled grains stay in the wheel, they simply keep on rubbing on work without actually cutting. This defect is known as glazing. If, on the other hand, the abrasive grains break away from the wheel, it causes a reduction in life of the grinding wheel. Grit. Grit indicates the size of the abrasive grain. It is indicated by a number. Higher the number, smaller the size of grains. The grade refers to the hardness or strength with which the bond holds the abrasive grains of a grinding wheel in a place. The grade is indicated by the English alphabet, A to Z. A denotes softest, and Z denotes hardest grade. Grinding wheels are generally composed of the three elements: abrasive grains, bond, and pores. Structure denotes the spacing of the abrasive grains in the wheel. The lower the structure number, the denser the wheel. Structure numbers range from 0 to 14. Balancing. A grinding wheel is a fragile tool, which is used to get perfect service. Proper mounting and balancing of the wheel are very important. Any unbalanced centrifugal forces may crack the wheel or spoil. The dressing is the process of producing sharp edges on grains, conditioning worn grains on the surface of a grinding wheel. It is required when the wheel is dull or tired. Truing. The truing is like a dressing operation, by which wheel comes back to its original shape. Thus around the wheel is dressed, to make its circumference a true circle. Truing is done during fitting fresh wheel, and also it is necessary after the wheel has been in use, for some time to correct the non-uniform wear on its face. The different types of grinding machines are: bench-type grinding machine. This type of grinding machines are fixed on a table or workbench. Gear or pulley is fitted in it. For rotating the big-sized gears or pulley, a handle is also fixed. It contains 1 or 2 grinding wheels. Edges of cutting tools can be made with this grinder. Provision can be made to operate these machines by power. Pedestal Grinder.
Hey!
This types of grinding machines are operated with electric power. This is fitted on a pedestal frame separately on the ground. A grinder wheel is fitted each on both sides of the shaft of the electric motor. These are the most widely used in the workshops. Edges of all types of cutting tools are made with these grinders. Apart from this, molded articles can also be cleaned with it. Portable grinder. This is a small grinder operated with electric power. It can be easily carried anywhere. Grinding can be done by holding it in hand. It is used for cleaning the heavy welding jobs. On one end of the motor shaft, a grinding wheel is fitted, and on the other end a handle or switch is fitted for operating the machine is fixed, according to our convenience. It should be used carefully, since there is a possibility of getting an electric shock. Flexible grinder. In this type of grinder, an electric motor is fitted on such a basis that it can be moved in any direction. A flexible shaft is fitted on the motor shaft with the help of a coupling. On one end of the shaft, a grinding wheel and handle are provided. Precision grinder. In this type of grinder, a movable spindle is fitted in the grinding wheel. This spindle is fitted on a table along with the motor. With this spindle, the grinding wheel can be turned in forward, backward, left, or right direction, in running condition. Jobs of excellent finish and accuracy are grinded with it. There are various types of precision grinders are available. They are Cylindrical Grinder. The surface which has been made plane by shaper or planer are grinded with this grinder. The cylindrical surface is grinded with a machine, in which grinding wheel is fitted on the shaft of a free electric motor. In this type, the grinding wheel is fitted on the machine's work table, which can be given crossfeed and the entire surface of the job can be grinded. Plain cylindrical grinder. In this type of grinders, the job is rotated in chuck or center, and the entire cylindrical surface of the job is grinded. Finishing of sleeves, pins, rods, taper pins, and other operations are done with this grinder. Roll grinder. This type of grinder is used in steel mills, printing presses, and for grinding heavy rollers. Piston grinder. Pistons of IC engines are required to be grinded not in round shape, but in oval and taper shape, so that when their size increases due to heat, these may not get deposited in the cylinder. So because of that, this grinder is specifically made for these shapes. Plunge Cut Grinder. These grinders are used to grind small shafts. The diameter of the grinder is much more than that of the job. The crankshaft of motor vehicles are grinded with this grinder. These are also called crankshaft grinding machines. This type of grinder is also made in a different form, for camshaft grinding. In order to save the shaft from becoming flexible, steady rests are used. Form grinder. Grinding wheels of different shapes are made in this type of grinders. Wheels are given feed and accurate grinding is done, as per the shape of the grinding wheel, on the moving cylindrical surface. Thread grinder. This type of grinder is used to cut accurate threads. Grinding wheels of the size and shape of the thread are used. Gear grinder. Different forms of grinding wheels are used in this grinder to cut dents of different sizes and shapes. Internal grinder. These grinders are used for grinding round and hollow jobs, whether the internal surface of these job is completely round, ditched round, or is in taper. Small grinding wheels of 3 cm to 5 cm are used in such grinders. Chucking grinder. In this type of grinder, job is held in the chuck. The grinding wheel makes the job accurate through grinding of its hollow part. Centerless grinder. In this type of grinder, for holding the job, the chuck is used. The job is moved through the medium of a grinding wheel and a regulating wheel. This type of grinder is used in modern workshops for mass production. Jobs of glass, porcelain, wood, rubber, plastic, iron and steel and alloy are polished and finished with this grinder. Surface grinder. Flat surfaces are accurately grinded with this type of grinders. The job is held directly by a magnetic chuck or work table. The race protecting table of plating or shaping machines is also used, in form of a table.
Okay, this is the types of the grinding machines and the operations. So this video we can learn the different types and the operations of the grinding machines. I believe through this video, you have all of you have the deep learning about the grinding machines and the operations. Okay, and then we will start study the grinding wheel and the designation and the selections. And the grinding wheels is a wheel, also kind of the cutting tool, which is made by mixing the appropriate grain size of the abrasive with the required band and pressed into shape. The characteristics of the grinding wheel depend upon a number of variables. The first is the abrasive type. They are hard materials with adequate toughness, which act as cutting edges for a sufficiently long time. They also have the ability to fracture into smaller pieces when the force increases, which is termed as friability. This property gives the abrasives the necessary self-shelter capacity. The common used abrasives are aluminum oxide, silicon carbide, and cubical bond nitride, diamonds, and so on. This is abrasive types. And two is grain size. The grain size means that the size of the abrasive grain, based on the stimulation in standard, this standard and the cost braid size is identified by a number which is based on the sieve size used. The sieve number is specified in terms of the number of openings per square inch. Thus, the larger the grain number, the finer the grain size is. The final grain size, called micro powder, is identified by sedimentation methods. This is the grain size. And the surface finish generated depends on the surface finish generated depends on the grain size used. And if you use the fine grains, it will take a very small depth of cut, and hence provide a better surface finish. And the fine grains are also used for making for grinding wheels. And the cross grains are good for higher material removal rates. These have better failability, and as a result are not good for intermediate grinding, where they are likely to chip easily. And when grinding soft materials with good practicity, if grinding soft materials with good plasticity, cross grains are generally used to make a grinding wheel in order to avoid jamming grinding wheels. And the third is band. The function of the band is to keep the abrasive grains together and the action of the grinding forces. The first is vitrified. This is the most commonly used band. It is strong, rigid, and porous, and not affected by fluids. It is suitable for various grinding operations. And the second is synthetic ring or rhinoid. It has good strength and is more elastic than vitrified bands. It is generally used for rough grinding, parting off, and high-speed grinding. And the speed usually can reach the 50 to 65 meter per second. And the third is rubber. Rubber is, of all the bands used, this is the most flexible. The band is made up of natural or synthetic rubber. It is generally used for cutting of wheels, regulating wheels in certain lathe grinding and for polishing wheels. This maybe four. And four is mentor of a band. This is used in the manufacture of diamond and the CVN wheels. This band has very high strength, good wheel resistance, but the disadvantage is this has a poor self sharpening compatibility. This is the band. This is the band. The usually the commonly banned materials we should know, including the metal or the vitrified synthetical ring or ring void and the rubber. This is usually usually used band materials. This is we should know. This is four types of the band. Okay. Maybe it's time for rest. Have a break. Okay.
Alright, okay.
Okay. Have a break. Hello everyone, it's time for class.
老师。
Okay, 老师。Okay.
Okay. Next class, we studied the band types. There are 4 types. The first is waterified, and the second is synthetic ring, and third is rubber, and fourth is metal. And the four is grade. The grade of the grinding wheel is also called the hardness of the wheel. This designates the force holds the grains. Or it means that the difficulty of abrasive falling of the grinding wheel in grinding. The grade of a wheel depends on the kind of the band, structure of the wheel, and the amount of the abrasive grains. Usually, greater band content and a strong band result harder grinding wheels. And harder wheels hold on the abrasive grease. Still, the grinding force increases to a great extent. And the grade and the core of the grinding wheels are listed in this table. From this table, there are different grade. They are super soft, middle, soft, and the medium, and the medium to hard, and hard, and the super hard. And this is the code. And this is the code of this grade. This is code of this grade. And in grinding process, the grades from L to N are used for grinding to steel without hardening. And this is from L to N. L to N is stand for the used for the grinding to the steel without the handing. And when the grade H to K are used for grinding the hardened alloy steels. And the grinding wheel with grade K and L. K and L should be selected when grinding the surfaces with high surface quantity. This means that this two grade the surface with the high surface quantity, and the grade wheel with grade H and J should be selected when the grinding are cemented carbide cutters. And the grade from H to N are mostly commonly used. This is a commonly used grade. This is the grade of the grinding wheels. And the 5 is a structure. And the structure of the grinding wheel represents the grains and spacing. It can be open. And medium and dense, as shown in figure and the next figure. and shows in this figure. Maybe in this figure. This is dense, and this is middle, and this is open. And the space among the grids allow for connecting chips and for carrying in cutting fluid into grinding region. The proportion of the abrasive grains in the total wheel of volume, and the smaller the proportion of powers, the denser the structure of grinding wheels. The opener the structure is, and is generally denoted by number as shown in these tables. And this is a structure from the structure from 0 to 3. This is the abrasive rate, and the density is dense, and the structure from 4 to 7. The density is medium, and the structure is from 8 to 12. The density is open, and the space between the grain along the chips to connect is shown in this picture. This is showing how the space between the grids help the clearing in the grinding chips. Is in this picture. And then is grinding machines. Grinding machines are generally classified based on the types of the surface produced. The grinding operation can be classified as cylindrical grinding. Cylindrical can be classed cylindrical grinding machines and surface grinding machines and the cantless grinding machines. All the machine tools which use the abrasive tools, such as the grinding wheel, abrasive belt, oil stone, and other abrasive materials to machine workpiece are called the grinding machines. This is a definition of the grinding machines. It's used to abrasive tools to machine workpiece. And the primary types is this. And the first we will introduce the cylindrical grinding machines, and it's including the external cylindrical grinding and the internal cylindrical grinding. This is a picture of the cylindrical grinding machines. They are including this in this part. The first this is grinding wheel. This is main machines, and two, this is the workpiece. Workpiece will rotate, and this is rotate feed machine, and this movement of the wheel grinding wheels. This is longitudinal feed machines, and for this direction, this is feed in feed machine, and this is in feed machine. This is the external cylindrical cylindrical grinding machines. And this picture shows the universal cylindrical grinding machines. This is cylindrical machines. It can be used for grinding the internal. This can be used to grinding the internal and external cylindrical surface and the face of the shaft, shoulder, and so on. And the work table, this is work table 3, is driven by the hydraulical power or manually and moves along the longitudinal guideway on the bed 1. And this is bed 1. They are an upper work table and a lower work table. The up work tables can swell an angle related to the low in horizontal plane in order to grind a long coin surface. And 2 is the surface grinding machine, and 2 is the surface grinding machines. And the surface grinding machines are usually used to generate the flat surface. These machines are similar to milling machines in hand structure as well as machine. In right of grinding methods and outlet, there are basically 4 types. There are basically 4 types of surface grinding machines. This is shown in this picture. There are 4 types of the machine surface grinding machines. And the first is this. This shows the type with horizontal spindle and reciprocating tape. In this picture, we can see that. And this picture shows the type with horizontal spindle and rotating table. And the table is rotating. And the spindle and with the spindle. And the 3 picture, and this C shows the type with a vertical spindle and the reciprocation table. And this table, we can see that it shows that this is rotate, and this type of rotational spindle and rotating, and the table is rotating. This table and this just kind of the movement of in nano movement. This is a surface. This is a surface grinding machines, and this surface grinding machine is similar to the mill machine in construction and motion. And the surface grinding has a high grinding efficiency, and the official grinding has a better machining quality. This is the surface grinding machines. And the 4 is the gear cutting machinery and cutting tools. As the gear transmission has many advantages. It has found widely application in mechanical drive systems, with the development of the transmission technology, the requirements for gears are getting higher and higher. So with the development of the industrial, the requirements of the gears are getting higher and higher. There are many kinds of gears in mechanical drive systems. There are many kinds of gears in mechanical drive systems. In this picture shows commonly used gear or transmission gear transmission types. The first is A this. This is the spar gear transmissions. This is the spar gear transmissions, and B is nickel gear transmissions, and this is here nickel gear transmissions, and three is heroable gear transmissions, and the 4 and the D is spiral gear transmissions, and E in this is worm gear transmissions, and the F is internal gear transmissions, and the G is rack and the gear transmissions, and the H is straight behavior gear transmissions. This is commonly used gear transmission types. We should know. And then, this is the gears manufacturing methods. We can study through a video.
Gears are mechanical components used to transmit power and motion through the successive engagement of their peripheral teeth. Gears perform certain key functions within machines and assemblies, such as reversing the direction of rotation or altering the angular orientation of rotary motion. Gears are also used to convert rotary motion into linear motion and vice versa, or to alter gear speed ratios. The methods of machining gears can be classified into two primary categories: gear generating and gear form cutting. Many of the processes used to machine gears may also be used to finish gears. Gear generating involves gear cutting through the relative motion between a rotating cutting tool and the generating motion or rotation of the workpiece. The primary gear generating processes include hobbing and shaping. In hobbing, using a helically fluted cutting tool called a hob. Both the hob and the gear blank rotate as the hob is fed axially across the face of the blank. Hobbing is the principal method for producing spur gears and helical gears, and is also used to produce many special gear forms. The main limitation of hobbing is that it can only be used to produce external gears. Hobbing can be performed on a single gear blank, but also allows for the stacking of workpieces to increase production rates. Shaping generates gear teeth by rotating the workpiece in contact with a reciprocating cutter. The reciprocating cutter may be a pinion-shaped cutter, a multi-tooth rack-shaped cutter, or a single-point cutter. The pinion-shaped cutter's axis is parallel to the gear blank, and begins cutting by reciprocating while feeding gradually into the blank to a predetermined cutting depth. The cutter and gear blank rotate slowly at the same pitch circle velocity as the cutter enters and exits the cut, incrementally generating the gear teeth. Rack-shaped cutters typically have between 6 to 12 teeth that reciprocate into the gear blank. Once the rack cutter finishes a pass, the cutter is disengaged and returns to a starting point to begin cutting again. When shaping with a single-point cutter, the cutter reciprocates, making successively deeper cuts until a predetermined depth is reached. Gear shapers are used to make internal gears, shoulder gears, and many other gear types that cannot be produced with hobbers. Shapers can also produce non-involute shapes, such as a cam and gear on the same shaft. Gear form cutting typically involves the use of formed tooth cutters that have the desired gear shape or profile. The primary gear form cutting processes include broaching and milling. Broaching is the fastest method of machining gears and is performed on many different machine types using a multi-tooth cutting tool called a broach. The broach or the gear blank are pushed or pulled relative to each other to remove material. Each tooth on the broach is generally higher than the preceding tooth. As a result, the depth of cut increases with each tooth as the broaching operation progresses. The conventional method of broaching is used mainly to produce internal gears. For external gears, pot broaching is used. Pot broaching is performed on special machine tools having a hollow broaching tool assembly called the pot. Gear blanks are either pushed down, pushed up, or pulled up through the pot to generate the gear teeth. Milling is a machining process that uses the relative motion between a rotating, multi-edge cutter and the workpiece to generate gear shapes. Milled gears are typically produced using cutters that mill each gear tooth space individually. To produce large, coarse-pitch internal or external spur, bevel, or helical gears, a process called gashing can be used on heavy-duty milling machines. Gashing involves plunging the rotating cutter into a blank for rapid metal removal. After machining, gears may require heat treatment to meet hardness requirements. After heat treating, gears usually require finishing to nullify any distortion that may occur. In some cases, gears are machined and finished before heat treatment, and then once processed, surface finished to remove distortion from the heat treatment.
Okay, this is the gears manufacturing methods. We have from the video we can learn about the gear cutting methods and the gear forming, and then we will study the gear forming. In the there are many kinds of the gear cutting methods. Based on the tooth machining principle, gear cutting methods are described are classified as gear forming and the gear generation. From this video, we can know that the main method to gear the gear cutting method is a gear forming and the gear generations. In the processes of the gear forming, a form cutter with the shape of the gear tools is used to cut gears. The gears forms medium gear form grinding, and the gear branch belongs to the gear cutting method. This is a gear forming process. And then is a gear generating, and this is gear generating. To obtain a more accurate gears, the gear is generally generated using a cutter, which is similar to the gear with which it's meshed by following the general gear theory. If the model and the prior angle of the gear cutter are the same as that of the gear to be cut, one cutter theoretically can generate all gears, regardless of the number of the teeth. All the teeth have the correct profile and mesh correctly. The gears produced by generation are more accurate, and the manufacturing process is also fast. They are used for cutting gears. They are used in cutting gears in the large volume productions. There are several gears generating methods. The first is gear shaping, gear hobbing, and the gear shaving, and the gear honing, and the gear generation grinding. This is some of gear generating methods. There are many include this. The gear produced by generation are more accurate, and the manufacturing process is more faster. This is we should know that the gear generating has a more accurate, and the manufacturing process is more faster. This is we should know. And then is the gear hobby principle. This the machine tools which are used the gear tools are named as gear cutting machines, and they are the gear hobby machine is one of the most widely used gear cutting machines. This is the most used the gear hobby machines. The gear hobby simulates the machine process of a pair of the helical gears, based on the gear generation principle. The gear, as shown in this picture, the gear hobby simulates the mesh process is shown in this picture. If one of the two machine gears has only several teeth have several only several teeth or even one teeth with very small pitch angle. The helical gear became a wall, as shown in this picture. And after throttling and relieving the frank on the wall, from this picture, and relieved the frank on the wall became a hob. This as shown in this picture from this direction. This is the gear hobby principle. And 2.4.3 is gear cutting tools. The gear cutting tools are used to cut gear tools. There are many kinds of the gear cutting tools with the complex structure in order to machine different gears. The gear cutting tools are the organized into gear forming cutters and the gear forming cutters and the gear generating cutters. The first is the gear milling cutters. This is the gear milling cutters, and the common commercial gear machine cutters are valuable as a set for the given model. This can be used on either horizontal axis from this or the vertical axis milling machines. There are two types of gear milling cutter, and this is a figure type gear milling cutters, and the type, and this is the gear generating cutters. There are many kinds of the gear generating cutters, but the most often used gear generating cutters in production in practice are hobbles, gear shaping cutters, and gear shaving cutters, as shown in this picture. The first is a hob, and the cutter itself is equivalent to a gear, which means with the gear to be cut in gear cutting process. This machine is named as the generating machines. And the first we can see that the hob, and this is rotation, and this is the movement of the movement, and this is the gear shaping cutter, and the three is gear shaving cutters, and D in this is special gear milling cutters. This is type of the gear cutting tools. There are many. There are two types. The first is the left is gear forming cutter, and the right is the gear. Two types of the gear cutting tools. And 2.5 is the other machine tools and the cutting tools. The first is the hole making machine tools and the cutting tools. About 1.0 for hole making operations in the machining operations, and the drilling machines and the boring machines. Boring machines are the most used. As first, we will introduce the drilling machines. The drilling machines is this all machines which are mainly used to drill holes by means of drills are named as drilling machines. And in addition to drilling machines can also be used for core drilling, reaming, tapping, countersinking, counterboring, and the spot facing and spot facing and so on. Is kind in shape and size. And the shape and size. The drilling machines comes in various of shapes and the type and size and the type. And the type they are two commonly a type. One is upright drilling press, and two is radial drilling machines. And the upright drilling press is comprised of a bicycle or a table, a work table, a spider head, a corner, and other components. And then we will introduce the boring machine. The boring machine are usually used for enlarging the existing holes on a large and the heavy workpiece. In addition to boring a hole, this is boring machines. In addition to boring a hole, boring machines can also be used for drilling, and core drilling, reaming, and tapping, surface milling, and the type of the boring machine is mainly the horizontal boring machine and the jiggle boring. And the first this is a horizontal boring. Horizontal boring machine are very versatile and useful in machining large parts. The structure of these machines are shown in this picture and this picture. And giggle boner is a kind of universal boring machine with a high pressure. The precision of the jig of boring is higher than the horizontal boring. This is we should know. And 3 is hole making cutting tools. There are various kinds of hole making cutting tools. In the light of the UL, they fall into 2 characters. One is used for making the hole in solid materials, such as one is making the hole in the solid materials, such as twist gel, canter gel, spade gel, and deep hole gel. And is enlarging the existing hole or improve the hole equality in such as the core gel, counter bowling, and the counter seeking gel, and the reamer and bowling tools. This picture is the structure of the standard of the twist gels. Twist gels are the most widely used the hole making counter tools, which are especially suitable for rappelling holes with the diameter less than 30 millimeters. This is the structure of the standard of the twist gels. The basic consists of 2 parts. The first part is operation part, and two is one is operating part, composed of the guiding part and the cutting part. This is 2 parts. This is mainly 2 parts, and this is a structure of the twist journey. So study we know that the hole making cutting tools are mainly in 2 types. The one type is making the hole in solid materials. It shows the workpiece have no holes before the manufacturing. And the other type is enlarging the existing holes or improving the hole equality. And this is two type of the hole making in tools. And then is we will introduce the milling machines and the milling cutters. After there are a large type of milling cutters available to meet the specific requirements. This is used after lasers. Milling machines are the most widely used for manufacturing applications. Surface is flat or curved, inside or outside. Almost all shapes and sizes used to be machined by milling. This is mainly used for surface manufacturing after lathe. The workpiece is fed into a rotating milling cutter, which is multi-point tools, unlike a lathe, which uses a single point cutter tools. This figure shows the different of the mini operations. And the first is manufacturing, meaning the slides of plane surface, and the B is slide meaning, and the C is keyway meaning, and D is a T-shot, and the T-shot is a T-shot, T-slot meaning, and E is do V-tail meaning, and F is gear forming. This is gear forming meaning, and F is and F is a gear for meaning, and G is thread meaning, and H is a spiral grooving, and I is a profile meaning, and J is surface cantling, and this is surface cantling. This is type of the milling operations, and the type of the milling machines. There are two types of milling machines. The first is a horizontal key and the column type milling machines. From this picture we can see that the horizontal it is many horizontal knee and column type milling machines are composed of this part. The first is one is a column, and B and the two is and maybe this is over arm, and three is arbor, and four is work table, and five is this is a sandal, and six is this is outboard support, and seven is a nail. 7 is the nail, and the 8 is the base. This is the horizontal nail and the column type milling machines. And the second is the vertical nail and the column type milling machines. Its structure is very similar. The structure is very similar with the horizontal nail and column types. Vertical axis milling machines is relatively more. From this picture, we can see that this machine has more flexible and suitable for manufacturing complex cavity, such as their cavity in tool runs. And the vertical head one is provided with severely facility in a horizontal plane, whereby the counter axis can be survived. This is the two types of milling machines. One is horizontal or near and column type milling machine, and two is vertical near and the column type machines. and the last is milling cutters. They are many large or variety of the milling cutter available to meet the specific requirements. There are many include the slab milling cutters. Slab milling cutters from this picture we can see, and the face milling cutter, and the end milling, and this is the end milling cutters, and 4 is side and face milling cutters, and the last is other milling cutters. This is types of milling cutters. There are many 4 or 5 milling cutters. This is we introduce the milling cutters. Okay. Thank you. This is all the contents in this chapter. We learned the
Alright,
okay.
Alright.
Okay. Have a note. Please pay attention. The next Monday is a holiday. And our next class will be the Friday.
On Friday,
Okay?
yeah.
Yeah. Next class is Friday.
Okay, 老师。
Okay. This is all the content of this class.
老师, please can you send us the PPT? Thank you.
Yeah. Okay. I will show my PPT for you. Okay.
Okay, 老师.
This is all the content of this class. Happy holiday, everyone. Okay.
Thank you.
Good holiday, you too. Thank you.
Okay, thank you. Bye. This is all the end of this class. Okay.